Before we had self-driving cars and digital assistants, the dream of creating intelligent machines was just a fascinating, almost philosophical concept, debated in hushed academic circles. It all truly began with visionaries like Alan Turing, who dared to ask the profound question, can a machine actually think, setting the stage for everything that followed? The official birth certificate for the field was issued in 1956 at the legendary Dartmouth Workshop, where the term artificial intelligence was first coined. The initial decades were filled with incredible optimism, as early researchers achieved impressive feats in solving complex logic puzzles and proving theorems. However, the lofty promises made by those pioneers proved incredibly difficult to deliver upon, leading to the first major funding drought known as the AI winter. As the 70s faded, the focus shifted towards building specialized expert systems designed to replicate the deep knowledge of human professionals in very narrow fields. Despite this resurgence in niche applications, the fundamental limitations of the underlying symbolic programming led to another period of disillusionment and reduced investment. By the 90s, the entire paradigm began a critical transformation, slowly moving away from hard-coded rules toward the statistical power of learning from vast amounts of actual data. A landmark moment arrived in 1997 when IBM's Deep Blue defeated the reigning world chess champion, a symbolic victory for machine calculation over human intuition. The explosion of the internet and massive digital data storage finally provided the raw, endless fuel needed for these statistical learning models to truly begin their dramatic ascent. This era paved the way for deep learning, a revolutionary approach utilizing complex, multi-layered neural networks loosely inspired by the intricate workings of the human brain. Suddenly, machines were not just counting or processing information, but actually seeing and recognizing objects within images with startling, human-level accuracy. Concurrently, the ability for machines to process, understand, and actually generate human language took enormous strides, moving far beyond simple command recognition. The mastery continued in 2016 when Google DeepMind's AlphaGo conquered the ancient, highly intuitive game of Go, signifying a new peak in strategic capability. Crucially, this massive progress was heavily dependent on advances in specialized hardware, like powerful GPUs, which allowed these enormous models to be trained efficiently for the first time. The introduction of the transformer architecture became a true inflection point, fundamentally changing how sequence data like text could be modeled across extremely long, complex contexts. This breakthrough led directly to the rise of today's powerful large language models, capable of writing functional code, drafting sophisticated reports, and engaging in remarkably coherent conversation. What was once locked away in specialized university labs is now increasingly accessible to everyday creators, developers, and businesses everywhere, sparking an era of rapid application. As this incredible technology becomes more deeply integrated into our daily lives, the conversation rightly pivots towards ensuring its development is responsible, fair, and transparent for absolutely everyone. From a simple philosophical question asked decades ago, artificial intelligence has evolved into a powerful transformative force, shaping our present and undeniably dictating the shape of the world to come.